Okay, so we're learning how to rationalize the denominator. Suppose we have a fraction and it has an irrational denominator, such as shown over here. We can write this fraction with a rational denominator by doing a bit of a long step. Basically, what we do is we find something called the conjugate of the denominator and we multiply both the upstairs and the downstairs by the conjugate. So this is going to become b minus root c, b minus root c. Now this looks eerily familiar to what we were doing before, where earlier we were expanding the difference of two squares situation. Look what happens when we write this thing as a whole fraction. It turns into a situation where you have the difference of two squares in the denominator. And this is the condition that we're trying to trigger, which will enable us to rationalize our denominator. So this is just the, theory at the moment. This is the rule we follow. Before we move on, the upstairs and the downstairs we have here, this is called the conjugate. Conjugate. It's a fancy word that says it's one of the terms is the polar opposite to, its conjugate expression. I'll write a little side note on the board after we go through this. Seem okay, guys? Okay. Let's go into an operation here. Rationalize the denominators in the following. We'll go A. Let's go 1 over 2 plus root 3, like so. Have a look at this. Do we have a rational denominator at the moment? Not yet. So what could we do to rationalize the denominator in this fraction? Times the numerator and the denominator by what? The conjugate of the denominator. So I can put my times symbol there and I'm going to multiply the numerator and denominator by the conjugate of this guy here. The conjugate is going to be 2 minus root 3, because all you need to do is flip the polarity of one of the terms. You could do the 2, you could do the 3, root 3, it doesn't matter which one. I just do it because it looks a bit tidier doing it this way. 2 minus root 3. It's at this point where when we go down to the next line, we bring our fractions together. This will be 2 plus root 3, 2 minus root 3. Upstairs we have the 1 outside, 2 minus root 3 inside. Now, do we have a fast expansion method we could employ to expand out the denominator? It starts with D. Zoe, do you remember? Difference of two squares, dots. Put that piece of vocabulary in your vocabulary. Okay, expanding this out using dots, we square this we square this, and we take the difference. That's all under. Expanding this out, it's 2 minus root 3. Simplifying downstairs, we have 4 take 3. And then we have 4 take 3 is 1. So it's just going to be 1 under 2 minus root 3, which is 2 minus root 3. And there's our answer. Not only did we, oh, that worked out nicely. Not only did we rationalize the denominator, we got rid of the fraction altogether. Wow, what a time to be alive. That question's beautiful. Okay, your turn. First degree of complexity. Give me your favorite numbers, please, Alex.
8.
8 upstairs.
9.
9 downstairs.
What?
One more.
3.
And final one.
4.
I like 4. Well done. Okay, can you rationalize this? Rationalize the denominator in this fraction here for me. Do we agree? May have made a mistake. Okay, if we want to check to see if we're doing the operation correctly, we can use our technology. Much like last lesson, in most situations, or basically in all situations in a test, if you were presented with a problem like this, you would use your calculator unless I told you to algebraically show. But in most situations, you'd use your calculator. So if we put in 8 over 9 plus the square root of 3, it will show us the most simplified version we can get to. If you got up to this step here, that's fine, because you've satisfied the requirements of the question, rationalize the denominator. If you got up to here, it would be the same marks because it's still rationalized. Does this seem reasonable, guys? Is there anything that we're not sure about or something that just doesn't make sense? Okay. We're not changing any values here. We're simply changing form. We do this because in some questions it is practical to have your numbers in a form such that the denominator is rationalized. We're not going to go into any examples yet, but when we get up to stuff like calculus and the complex part of the complex numbers topic we're currently in, it'll make perfect sense why we do this. In short, one of the applications coming up is division. We can't divide if we can't do this. Okay, the final thing, it's just notation. Do you see how I've got b plus root c and then I've got a bar on top? The bar over the top of an expression means conjugate. Similarly, the star or the asterisk also means the same thing, conjugate. To practice today's concept, we're on learning intention 4. It's 7C in the chapter or in the textbook. We have presented to us some fairly routine questions, but they're going to seem hard because it's probably the first time you're doing it. So question 1, question 3, question 5, question 6, question 7. 5 and 7, you're solving equations. Yep, you're solving equations. I'll give you a little bit of a hint or toward the end of the lesson on what to do. And then question 6, did you guys do similar triangles in year 9? Where you're showing that two triangles are the same or two triangles have the same ratio. Did you guys do that at all? Maybe? Okay, we might save question 6 for the start of the next lesson. Have a go at it, but we'll go for a formal explanation next lesson if you get stuck. If you haven't been shown similar triangles, you can't really do it, so don't get stressed out over that. So this is our challenge today. If you need any assistance, guys, let me know and I will help you with it. But this is part of our bread and butter for complex numbers, so we need to master it.